Hey guys, Mr. T here in the next video, difference of two squares factorization. This should help you out with exercise 2D.2. So in our previous topic, we expanded things that look like this, bracket a plus b times by bracket a take b, and we saw that if you fold that out, your result would be a squared take b squared. So we just suggested that you use this shortcut and use that to get your answer. So, if we establish that brackets a plus b, brackets a take b, equals a squared take b squared, that works both ways. An equal sign works in both directions. So, if you see anything in the form of a squared take b squared, you can factorize it back, return the brackets to this form again. So, that is the next next type of factorization that you need to be aware of and be able to do. It's called difference of two squares factorization. So the secret here is to find the a squared part and the b squared part, and sometimes you need to do some maths to get to that situation. So here we have two terms, 9 take x squared. Does it say 9 squared? Is it squared like we would expect it to be based on this? No, but if you understand squaring of numbers and you know your times tables, well, 9 is 3 times by 3. And we've still got x squared there. And 3 times by 3, or any number times by itself, is squared. So we have 3 squared take x squared. And now do you see that this is in this form? Hopefully you do. We have a squared, which is 3 squared, and b squared, which is x squared. One's being subtracted from the other, so we can use that shortcut to factorize it to a plus b in brackets times by a take b in brackets. So a in our situation is going to be 3, and b is going to be x, so it's it's 3 plus x, not a, getting confused there. 3 plus x, 3 minus x. And if you're not sure, or if you want to just double check with me, let's see if expanding that out again gives the original answer. 3 plus x, 3 take x. If you fold that out, would be 3 times by 3 plus 3 times by negative x plus 3 times by x plus x times by negative x, 9, negative 3x plus 3x, negative x squared. Negative 3x and 3x cancel out, so it's 9 take x squared, which is the same as before, so you can confirm that that rule works. That is the opposite of difference between two squares expansion. That's difference between two squares factorization. That's the first example. It gets a bit more tricky now. So last time I brought 9 down to 3 squared. Sometimes you're not going to be able to do that straight away because there is nothing squared that will give you 2x squared. So you might actually have to use some of your factorization from the previous exercise. That's what school is about, that's what learning is about. You need to use stuff that you learned before to do things. If you wrote this out, it's 2 times by x plus negative 2 times by, let's say, 4. Or what's a different way of getting negative 8 where I'm going to use positive 2? Well, I'll change this to a plus, and let's say it was times by negative 4. So what you have here is I'm using factorization from before, common factors, to try and break this down so I can do difference between two squares. And you'll see that 2 is common to both of these terms. So I can go outside brackets, 2, and what do I have left over? X times by x, which is x squared. That's that. And plus negative 4 is the other thing left over, so take 4 is what I have left over. So now you see you have two situations here. You've got 2 outside of the brackets, but this x squared take 4 is the same situation as this. Okay, it's something squared take something else squared. But we need to break that 4 down into something squared. So x squared, what do you square together to get 4? Well, 2. 2 squared. And so now we have a situation that is a squared take b squared, and we can put that into the brackets for factorization. So it's going to be x plus 2, x take 2, and that is that fully factorized. Okay, so I'm using multiple layers of rules to get the fully factorized answer. The last one here looks a bit tricky, but it applies the same rules. If you notice here, it is something squared take something else squared already. But what is a this time? It's 3x plus 2 all squared take 9, which we have seen already before is 3 squared. So, just like before, like I showed you, we have this situation again, a squared take b squared. It just looks a bit more complicated, but we have seen that a squared take b squared can be factorized to a plus b, a take b. You just need to be a bit more careful as to what a and what b are here. This one is a, this one is b. So when I factorize it, it's going to be 3x plus 2 plus b, which is 3. And then the end of the bracket is a take b, so this part is this, and this part is going to be here. So it's going to be a again, 3x plus 2, take b, which is 3. So when I finish here, because we've got multiple sets of brackets, we need to deal with them. Is there anything more that I can do with this set of brackets? 3x plus 2, I can't collect them, I can't do anything, so the bracket can be removed. 3x plus 2 plus 3. Is there anything else I can do with this set of brackets? Well, 3x plus 2, I can't collect like terms, so they can be removed. That grouping can be removed. And so 3x plus 2 plus 3 is going to be 3x plus 5. 3x plus 2 take 3 is going to be 3x take 1. And so that is that initially complicated looking thing broken down into this situation of a squared take b squared, showing you how it was factorized, just being careful with the brackets and the grouping. And there you have your final fully factorized expression. So hopefully that helps you out. That was difference between two squares factorization, and I'll see you in the next video.